Okay, welcome back. Next up is Johnny Hatch, who leads our enterprise monitoring and analytics practice at AHEAD. He's going to discuss the concept of observability, but in a public cloud context, another dimension of day two operations. After Johnny, we'll go to our final session of the summit, led by AHEAD's Ryan Hale and Pam Coffey, on the role of service management and ServiceNow in scaling public cloud adoption in the enterprise. Enjoy these sessions, and again, please ask questions via chat. Johnny, over to you.
All right, well, thank you, Tom. Hello, everyone. My name is Johnny Hatch. I am the Practice Director for Enterprise Monitoring and Analytics here at AHEAD. Early on in my career, I worked in IT environments where the size and the scale of infrastructure was small enough where we could give our servers names. Each cluster of servers that were grouped together would all have names based on a certain theme. That could range from movie themes to sci-fi, sports teams, famous places, you name it. During any given incident, it would not be uncommon to hear someone shout out over the cubicle wall, "Hey, I think Bilbo is running out of disk space." Or, "I need help over here. Boromir is down." Because these environments were historically static in nature, monitoring these systems and the apps that run on top of them, it was a one and done type of setup. Well, now fast forward a few decades, and the size and scale of our IT operations is vastly larger. It's increasingly ephemeral in nature. So setting up a monitoring and an observability strategy is no longer just a one and done type of implementation. So let's take a look at some of the typical workflows that we're now seeing enterprises start to deploy to handle these systems at vastly larger sizes and scales. All right, so first of all, everything increasingly is more and more about the developer. So let's start with the developer workflow. They might start by checking in source code into their source code management repository. It might be a GitHub repo. From there, that GitHub repo will have a webhook that triggers a build server. Maybe they're using something like a Jenkins here that will go and compile the code, and it can make call outs to additional scripts in the environment. Maybe one of the call outs that it makes is to trigger Terraform to build out infrastructure in a codified way. They're deploying infrastructure as code. From there, there might be some type of config management tool. You might be using something like a Puppet or a Chef or an Ansible. One of the things that config management tool can do is it can go load a monitoring or observability agent. In this case, maybe we're using Datadog to monitor our infrastructure. And so from there, not only do we want to have our agents deployed, and once we reach a production state environment, we also want to have a proper incident response workflow as well. And so now let's say that we've got a handful of different monitoring or observability agents deployed. Could be Logic Monitor for our infrastructure. It could be an Elk Stack for our logs or Splunk. It could be AppDynamics for APM for our application performance management and our distributed tracing. One of the common things that we're hearing from a lot of our customers is that as they deploy more and more monitoring and observability tools to give them full stack visibility, increasingly, I'm hearing service desks say, "I'm playing whack-a-mole with all the alerts and events that are starting to pop up, and I need a way to separate the signal from the noise." Well, that's where we're seeing organizations start to deploy event correlation tools, tools like, say, Big Panda, that can help you pare down and say, "Hey, these 37 alerts that all came out of my observability stack, they all stem back to the same root cause. And so let's filter that down and let's write one incident record into our incident response tool or into our ITSM system." So from there, once we have everything tailored down to just the alerts that represent one single problem, we can notify or alert or escalate using a tool like a PagerDuty. PagerDuty can have a call or a workflow into some type of workload orchestration or automation tool to say, "Hey, let's balance out the infrastructure to scale it up for the needs, the performance requirements that we have, but at the same time, we want to balance that for cost." As new systems might get scaled out or scaled in, or automated scripts get run to remediate an environment, well, we want to tie that all back to our ITSM systems now. So we have a audit trail of what changed in the environment. What were the problems or incidents that occurred? And if any new assets or new CIs, any configuration items were run, well, we want to document that in a CMDB. So this is a great workflow, but I think we can do better. We can take this a step further. And that is what I want to now highlight in today's session, is in the same way that in that previous slide we talked about Terraform and infrastructure as code being one method or one step that organizations are taking. Well, let's also now codify our observability and our incident response. There are a number of vendors increasingly that are releasing providers for Terraform. So in the same way that we have codified the servers or the storage or the pipelines within our environment, well, now we can, in that same code block, we can also define who should be notified via an incident. What are the types of dashboards that I want to have created in an automated fashion? What are the thresholds that should be defined for a monitor? And so now from here, what I want to do is I want to dive into a demo, and I want to start walking through some basic workflows and show you real code on how organizations are leveraging these different Terraform providers to start marching toward not only an infrastructure as code reality, but also an observability as code reality. So let's dive into the demo.
Okay, well, let's dive into the demo here. So first of all, you'll notice that I am using Terraform version 0.13 for this demo. If we look over at the code here, I've got a handful of files open up. The first file right here is my provider file. And so I am using and pulling in PagerDuty, Datadog, and AWS are the different providers or resources that I'm going to be using throughout the demo here. You can see that I've got some variables defined here so that way I can interact programmatically with each of the different services from PagerDuty, from Datadog, and AWS. I've got them defined here in a variables file, and then the value of the variables, my actual API keys, are listed in my terraform.tf-var files, which I have also included in my gitignore. So I can check all this in to source code management, and I don't have to worry about any of my secrets being stored publicly out there in my GitHub repo. All right, well, first of all, what I'm going to do is I'm going to go ahead and execute or apply this Terraform plan, and then we will walk through the code here. So let's do a Terraform apply. I'm just going to auto approve this for the sake of time. That is going to kick off my Terraform run here and start provisioning and creating resources. This should really only take 1 or 2 minutes here to provision, but while that is going, let's start walking through some of this code. So first of all, let's talk through AWS. What I'm doing is I'm instantiating a new EC2 instance that I'm just simply calling example. I'm grabbing an Amazon machine image using a T2 microservice, T2 micro instance. I have a key pair that I am using, which I've defined as a variable, and so I can call out exactly the key pair that I've already created that I'm using. And then I've also defined a VPC security group here. I've got a short little bootstrap script. One of the things that I'm doing is I am installing the Datadog agent. Again, you can see where I'm using a variable here to pull in the Datadog API key. And so I can go out and make sure that that agent automatically has the API key plugged in so I can reach back out to the Datadog service. And so when that EC2 instance boots up, it can phone home and start registering all of my observability information. I've got some tags defined here, and then I've also got a security group defined, simply allowing SSH access into the instance. And so if we were to take a quick peek, yep, resources added. Let's jump over to my console right here. If I were to refresh, you can see that I've got my new demo instance up and running. I should be able to connect to it and grab this connection string right here. We can SSH into my instance. One of the things that I'm going to do for the sake of example here to highlight some additional workflow is I'm going to throw some stress on this system. Part of my bootstrap script, if we come back to the code here, is I'm doing an apt-get install stress, which is just a simple command line utility to put some stress on the CPU so we can trigger a monitoring threshold. All right, so let's go sudo stress CPU, 8 CPUs, and a timeout of 300 seconds. So while that's dispatching the hogs there, let's come back to our Terraform code and continue walking through what we have. Let's take a look at the Datadog code real quick here. So what I'm doing is I'm creating a new Datadog monitor. I'm calling it Datadog AOC monitor. AOC is what I'm using to stand for Observability-as-Code. I'm giving it a name, the type of monitor that I'm creating, and then in the event that this monitor actually gets triggered, here is the message that I'm using to send. So monitor triggered, and then I want to notify, and then I can give this @ reference to PagerDuty, which is one of the integrations that I've got set up here within the code. And then I am using some interpolation syntax here to make reference to the service that I want PagerDuty to alarm against. And so we can take a look at this service within the PagerDuty code as well. Here's the query that I'm monitoring for, and so I'm taking the average of the last minute of the system CPU of this host. Again, some interpolation syntax here, which is common within Terraform. And then here are the threshold values that I have defined. And so if my CPU gets to certain levels, if I want to notify it gets greater than a 4, which is a critical stage, then that's where I want this threshold to be triggered and notify. A little bit lower down here, you can see I've got my integration service set up. So this is where I'm creating a resource for PagerDuty integration. I've got the service name, which again, interpolation syntax here, I'm calling out the service name. Because I'm doing everything as code, I don't have the service created yet. This service was all created or instantiated at the time of this Terraform apply. And so if I were to come back over here and I want to look at the service and come over here to PagerDuty, I'm creating a PagerDuty team. I'm creating some users, assigning a role to these users. Here's another PagerDuty user resource. I'm mapping these users to the team that was created. So here's the team that I created, the users that I created. I'm mapping the users to the team. And then I'm also defining that PagerDuty service here. And so all of this, if I were to go back into the UI of both Datadog as well as into PagerDuty, I'll be able to see all of these new resources that have been created. You can scroll down a little bit further. Here's the reciprocal nature of PagerDuty integrating back in the Datadog, so that way I have bidirectional two-way communication. Datadog can call back out to PagerDuty, has API hooks into it, and then vice versa. PagerDuty has an API hook to write or talk back to Datadog. So let's go back over to our GUI here. If I look at my Datadog monitors page right here, you can see that I can filter by my name. And so here is that Observability-as-Code monitor that was created as code using my Terraform apply. You can already see that the stress that I was kicking off via that little command line utility is already starting to invoke some stress on the system. And so after another minute or two here, I should have this triggered. You can see here's that message that I defined as code, where it is calling out to PagerDuty to the Observability-as-Code service. If I go over into my PagerDuty UI, here I'm on the services page. I'll just refresh the page here. So if we were to scroll down a little bit, okay, so here is my Observability-as-Code service that I've defined. And then I've got some users. Johnny number 5 and Johnny Rocket were the two users that I had instantiated or created within my Terraform code. We can go back and look at that real quick Here are the PagerDuty users that I created. So the resource type is PagerDuty user. The name is Johnny number 5. Here's where I explicitly say Johnny number 5, which is what you'll see in our UI. So come back over here to the UI. If we look at our Datadog monitor, we can see that our CPU utilization is high. Again, after another minute or so here, this will trigger, and then what will happen is I can go into the incidents area within PagerDuty, and I will eventually see a new incident here. From within the incident, I have the ability to acknowledge or resolve any given incident. While we're waiting for that to trigger, let's go back and let's look at some other things that you can do. Within this service level, I can also create or define some integrations. You can see my Datadog integration came up here because I created that as code, but there are other integrations or extensions or add-ons that you can also create. Some popular ones would be a hook into ServiceNow. Another one would be a hook into Slack. And so now let's say that the monitor triggered and I now have a call out to PagerDuty. When I come in, I can document something right within PagerDuty here saying, here's what I'm seeing, here's some of the symptoms, here is next steps that I'm taking to try and remediate the issue. All of that can have multi-way sync integration with Slack. It can post that same comment that I just made in PagerDuty. It can post that out to a Slack channel, or it can post that into the incident table within ServiceNow, and then vice versa. Let's say that there is a service desk individual, someone on the service management team. They like to live in ServiceNow, so maybe the update that they make will be within the incident table within ServiceNow. Well, that will have bidirectional sync back into PagerDuty, as well as can push that back into Slack. And so no matter where you like to live, all of this can have multi-way integration and synchronization. So if we come back over to our Datadog monitor here, you can see that we are now in an alert state here. And so we can see where it starts to turn red here. If we come back over to PagerDuty, look at our incidents, we now have a triggered incident that is showing up. So I can click on this. I can say, yep, I acknowledge that this truly is an incident. What's going on here? I can drill into the actual incident. This is where I can make those notes. I'm seeing high CPU. Escalating to level 2 team. So once I add that note, if I had those integrations created with, say, Slack and with ServiceNow, this note would get written into that Slack channel as well as into the incident table within ServiceNow. Well, let's say now that the issue is remediated, it's over. I'm going to come back over here. I'm going to select this, and I'm going to say this has been resolved. All right, so I've resolved my incident. All right, so this is where things can get pretty interesting or unique in terms of where I can go from here. Let's say that this was all for test and development purposes. From here, I can go back and I can do a Terraform destroy, and I can tear down all of this infrastructure. When I do that destroy, it will tear down the service that I had created within PagerDuty, so I can clean up after myself. So this Observability-as-Code service will cease to exist. The users that I had created will cease to exist. The Datadog monitor that I had created will cease to exist. It'll tear down my EC2 instance. So often people think about infrastructure as code and codifying their EC2 instances or their Kubernetes pods and clusters. But we can do so much more. We can create our monitors, define our thresholds, identify the users that are going to be on call or that are going to be escalated to in the event of an issue. We can define those business or technical services, those applications within PagerDuty. There's so much more, and I feel like we're just scratching the surface now. We don't have a ton of time in this session, and so I would encourage you to please reach out if you want to dive in a little bit deeper here. Maybe the one last thing that I will comment on, let's say that instead of a test dev workflow that we've got going on here, that this is a production workflow, and I want to tweak something to my environment here now. What I can do for change management is, instead of just diving into the GUI here and going over to my team or my users or my escalation policies, my schedules, and tweaking a schedule, well, because I hopefully am managing all of this via source code management repositories, I can go create a new branch within my code, and I can tweak my on-call schedule or the escalation policy. I can add or remove someone to the team, and then I can submit a pull request. That pull request can be reviewed, it can be approved, and then when it gets approved and pulled into the master branch, I can have a workflow that says, hey, when I got some new code that is triggered in my master branch, do another Terraform apply. Terraform will then look at the state of my environment versus what has been defined as code. It could say, here's what's differed. Terraform will then go change the team, change the users, change the on-call schedule. So now if someone comes back after the fact and say, why wasn't so-and-so notified? Well, we can go back and we have a great audit trail of exactly what changed in our environment, who submitted the change request, who approved the change request, and when that took effect. And so, taking that GitOps workflow and approach can be really, really powerful. So with that, I'm going to go ahead, and because this is just a demo environment, I'm going to go clean up after myself, go run a Terraform destroy, and that will go tear down all of my infrastructure and all of my observability workflows.
All right. Well, hopefully everyone was able to grasp the demo, had a few takeaways that they can glean from this. So let's talk about what our goals were here that everyone can start thinking about as they envision how Observability-as-Code might work within their own IT environment. Number one of our goals should be faster development and better testing. More and more, we're hearing organizations say that the way in which that they are differentiating themselves from their competition, the way in which they are attracting and retaining customers, is by being able to release feature functionality. We're seeing organizations hire developers at an increasing rate to create these new digital assets, whether it be a web application or a mobile application. Some organizations are getting into the Internet of Things, into IoT. And so being able to equip and arm developers with the ability to release better software, because now they're monitoring that software and they can automate that process of releasing it and getting the fast feedback loop, the monitoring and observability part, the better the software is, the faster they can get it in the hands of customers. Another goal or objective is around change management. We're seeing a whole movement around GitOps. It may be that if we needed to change an on-call schedule and something goes wrong, and now the person who is supposed to be on call doesn't start receiving the alerts or the notifications that a critical system was down, well, that can be a problem. So we can go back and say, well, what happened? Why was that change not invoked? Or why did the person that we moved the change to respond? Well, now we can go back and we've got an audit trail history. So for example, let's say that we're doing everything as code from an observability standpoint, where we can go back to our GitHub repo and say, who submitted the pull request? What was the change that was submitted in that pull request? Who authorized that pull request? And we can go back and say, okay, yes, this is exactly what happened, who authorized it, so on and so forth. So we've got a very robust audit trail around everything that changed in our environment. We also have a goal of a centralized configuration repository. So now if all of our observability is in a central place, well, now we can point everyone to a single source of truth in terms of who's responsible for what and when. And then lastly, the goal that we want to make good on is we want our pre-production, our tests and our development to look as much like production as possible. So now that there's no surprises when we get to production, we can say we tested exactly that, and there's nothing left to human error, because when everything's codified, we remove that notion of human error, of things being done differently in our pre-production environments as well as in our production environments. And so with that, I'm going to move into a time of Q&A. All right, let's see here. So first question here. All right, so can you make it bigger? Apologies on the size of that. My understanding is that we are going to make this available as a recording afterwards, and so hopefully that will have some better resolution than what was displayed here for the conference. And then I'm always happy to do a one-on-one session with anyone, and we can really dig into more of the code on an individual basis. Let's see here. Next question. Let's see here. What if I'm not a Terraform shop? Are there other ways to codify my observability? Yeah, absolutely. There's a lot of popular configuration management tools out there. I'm seeing folks use Ansible, Puppet, Chef. That can be the main orchestration engine that organizations can use. And that can have hooks or ties into an Azure ARM template, into an AWS CloudFormation template. We're seeing a lot of folks utilize ServiceNow as a service catalog. And one of the powerful aspects of using ServiceNow is the business rules engine that you can build into that. So let's say, for example, someone goes and says, I want to provision a lamp stack. We can present that user with some t-shirt sizes, small, medium, large, extra large. We can ask them for a definition of what their purpose is. Is this for test and dev? Is this for production? If someone says this is for test and development only, well, we can then also limit those t-shirt sizes. So as soon as they click test and dev, we can say, okay, well, only small and medium sizes are available for cost containment reasons. We can have additional orchestration happening on the back end from there that can say, all right, well, let's run this Ansible playbook. And part of the Ansible playbook is to go deploy a monitoring agent as part of that deployment. So there are lots of things that we can do using various different software applications, depending upon what it is that your business has standardized on. All right, next question here. Love the concept, but embedding all the observability bits into every resource sounds like things will eventually get missed. How does this scale? Great question. So we've got one customer scenario actively being deployed right now. We're leveraging tags behind the scenes and various different modules. And so now the idea is that the DevOps engineer, the developer that is going and defining things as code, in this particular customer's case, they're using Terraform. And we can have some hooks into some higher level modules. So when they go and run their Terraform code, every single time it runs, there is a module that will get added on in addition to it. So that way they don't have to worry about the monitoring or the observability bits. It all gets linked in real time at time of deployment. All the developer needs to do is they need to tag, hey, what application is this? And we can grab that tag, and then we can have a whole set of modules that will get linked dynamically based upon the tag. So if someone tags this as saying, hey, this is prod, or they tag it as this is a certain application, well, based upon the business requirements that we've identified for that application, we can say, this is the amount of observability that we want, or these are the requirements. We've got, say, a higher level log retention for certain applications that might have certain regulatory guidelines. We need to keep the logs that much longer. And so that can be part of our logging pipeline in terms of log retention. So all those types of things can be added. And so those would be some basic tips and tricks, recommendations in terms of how this scales. In other words, back it out, put things into a modularized format, and then make it so that way the developer doesn't have to include that in every line of code. Rather, it just gets bolted on every single time. The next question. My company is still very early in our cloud journey. How well does this work on Prem? Well, in the case of Terraform in particular, it can still work beautifully well. Terraform does have providers for Kubernetes. Terraform has providers for VMware. So if you are running a traditional stack on premises, VMware is your platform of choice. You still deploying things in traditional virtual machines, or maybe you're running some type of Kubernetes stack on-prem. Well, you can use all the various different providers to go make this a reality, even on premises. From an observability standpoint, most of these providers are SaaS-based these days and have very open and flexible APIs. So as long as you are able to make some API calls from the code, again, whether it be that Terraform provider, whether it be some other type of automation tool, a lot of these things can be scripted. You just have to be able to know how to interact with or call out those vendors' supplied and accessible APIs. Let's see here. Next question. What do you recommend for a smaller IT department with a smaller budget? Is there a subset of these tools we should start with on a budget? Great question. In classic consulting fashion, I would say it depends. What is it that is most important to your business? If your business is primarily commercial off-the-shelf shrink-wrapped applications, I would say you probably want to focus more on the infrastructure monitoring side of things. If you have a heavy app dev environment internal to your organization, then I would focus on some type of APM, application performance management tool. One of the things that I highlighted at the beginning was this notion of event correlation. Typically, I see event correlation play out for larger enterprises that have large-scale problems. So if you don't have a large flurry of alerts because the size and scale of your IT environment is not large, I would say de-emphasize that. It's a fantastic capability to acquire, but typically requires some semblance of scale to make it worth your while. So focus on that which is most important to your business. Do you use infrastructure and the architecture of that infrastructure to maintain availability and performance? Or do you have a team of developers that are churning out custom code? And is that the code or those the applications that differentiate you from your competition, that provide the value add to your customer base? In which case, then that should be the focus of your observability and where you want to put the most emphasis on. And again, happy to chat one-on-one if you want to get real granular, and we can look at exactly your environment and what your specific needs are. Let's see here. Next question. What about dashboards? Can those be created as code? Yes. I find that a lot of the vendors out there, they have essentially JSON being used behind the scenes. And so what we've done, what we've seen other customers do behind the scenes, they will go ahead and mock up what that dashboard looks like, get their ideal defined state created, and then they can go pull the JSON from it, and you can typically variabilize some of the components that you may want to tweak, make different from environment to environment or application to application. And so you can then, if you like, embed that JSON within your Terraform code or within your orchestration and automation tool code. So that way you can have a reusable dashboard on an application by application basis. And so if you've got the main template, now you don't have to worry about creating dozens or hundreds or even thousands of dashboards. You got your core template that can be used across all of your different applications. And then based upon the variable, you can tweak that variable to say, all right, well, let's pull in via a tag per se. And now you've got a unique dashboard to that application. All right, let's see here. Next question. From your own experiences, do you have any sense as to the savings in time and effort this has for your customers? So as an organization gets bigger and as they scale, that's where you're going to save more and more time. You'd be surprised at how many organizations that we see that still do so many things by hand. And so size and scale of your environment, if it's really small, well, then the cost savings might be negligible. But most organizations that we talk to, they all want to grow. And so even if you are a smaller size and scale, it's worth the effort to start laying the foundation work now up front. So that way, as you grow, as you scale, you don't have to worry about the time investment and the technical debt that you accrue as you begin growing. And so, I would highly recommend that, it's something that you explore regardless of size and scale, but the bigger the size and scale, usually the bigger the cost savings are. And any efforts up front are going to pay dividends later on down the road. All right, let's see here. Observability can be logging, monitoring, tracing, performance. Is there a framework for picking tools from the CN ecosystem? I'm assuming CN being cloud native ecosystem. Again, classic consulting answer. It depends. Similar to my previous comment about, do you do a lot of in-house application development? In which case you might want to put more emphasis on a tracing tool, on an APM tool, or if you're heavy package software, off-the-shelf shrink wrap software, more of an emphasis on logging or on infrastructure monitoring. And then each one of the different tools out there within the ecosystem, they all have their different strengths. One of the things that we're seeing right now is that there's definitely a land grab where each vendor is trying to eat a bigger and bigger piece of that observability pie, being the three pillars of observability: your metrics, your logs, your traces. Some vendors grew up in the infrastructure monitoring, that metric space, and they're moving into the logging and the APM space. Other vendors I'm seeing start in the APM space, and they're either organically building out their metrics and logging capabilities, or they're going out and acquiring companies. And so, be asking yourself, what is of primary importance to me, and what is the core competency of that particular vendor, and that can help lead to a vendor selection process. All right, let's see here. A question coming from an org which is soon to start on-prem Kubernetes journey within heavy infrastructure as a service and DevOps with non-cloud native specific tools around observability. For example, AppDynamics may work well in non-Kubernetes environments, but it has some ways to go and evolve. So really getting into some vendor-specific questions there. I guess to my previous comment, every vendor is going to have their strengths and their weaknesses. They all got to start, somewhere. Some started in this cloud native ecosystem. Those vendors that are newer and were built or born in the cloud, if you will. Some of these other vendors might have a longer track record in really starting out in more of the traditional on-prem data center, more of that monolithic application stack. And so those are certainly things that you want to keep in mind as you look at your stack, regardless of on-prem or off-prem. I oftentimes like to refer to things as cloud native environments and not necessarily delineate between public cloud and private cloud. You should be treating your on-prem Kubernetes environments very similar to you would say if it was Kubernetes and running in a public cloud. It's the old adage, it's just someone else's data center. But a lot of the APIs, sometimes they might be specific to a certain public cloud vendor, but Kubernetes is still Kubernetes. Might be tweaked ever so slightly depending upon the vendor that is providing that as a managed service. But from an observability perspective, I would still treat that very much the same. And so again, just looking at the strengths, the weaknesses of each of these different vendors. All right, tools for event correlation. ServiceNow, Big Panda, something else. I'm seeing a big trend in conversations out there right now. When people sometimes talk about the monolith, they talk about it more than just as an application architecture, whether you've got a monolithic application stack versus a microservices-based architecture. Some people are now starting to use the term monolith as it relates to some of these vendors and the platforms that they offer. And I would say that this largely comes down to a cultural preference or choice. So in the event correlation space, this particular individual is asking about ServiceNow and Big Panda. ServiceNow grew up in the ITSM space. And they've got a very broad and wide platform. And we're big fans of ServiceNow. I think that they do a lot of things really, really well. But there are certain things that I think just naturally by scope of the size of the platform, they can't do everything amazingly well. They can do a lot of things really, really well. But you do have other vendors out there that have chosen to have a hyper focus on different areas of the stack and of the certain capabilities. And so, ask yourself, would you prefer as an organization culturally to have a single throat to choke, one platform by which you can do everything? And there's advantages to staying within an ecosystem. There's advantages to staying with a single platform vendor. Oftentimes there's very tight integration between their modules. Or do you have a cultural preference of going with a best-of-breed solutions provider? Oftentimes, those best-of-breed solutions providers will have unique capabilities, unique feature functionality that some of these large platform vendors may not have. And you got to ask yourself, do I value those unique feature functionalities, those extra bells and whistles? If you do, then you may want to have a best-of-breed approach. Sometimes this also comes down to the size and scale of your organization. The largest of large enterprises may have the bandwidth to take on additional vendors, to manage those vendors, because there is an overhead associated with having that many more tools and having that many more relationships that you have to manage. So there's trade-offs in everything. One of the analogies that I like to draw on these days is you're driving down the road. You've got the path, the IT operations path that you're headed down, and there's a ditch on both sides of the road. One ditch might be to overcompensate on saying, I want a single platform to rule them all, and I will not deviate course in any way, shape, or form. The ditch on the other side of the road might be to say, no, I want best of breed for everything. And I'm completely unwilling to put all my eggs in proverbial one basket. And so I think a healthy, balanced approach is always worth keeping in mind. And there may be scenarios where you take a best of breed approach in one aspect of your IT operations or of your DevOps environment, and there may be scenarios where you say, no, I'm going to go with a single platform because I really like the unique integration capabilities that vendor brings to the table. All right, question. What has been your experience with a cross-platform Kubernetes deployment, allowing container deployments to cross between private and public cloud platforms? So my particular experience is going to be hyper-focused on the observability use cases and the monitoring. And that definitely has implications in terms of vendor selection. One of the things that I'm seeing crop up right now is more and more of the public cloud platforms in particular are getting into the observability game. And so if you're all in on AWS, then maybe CloudWatch and X-Ray and some of these tools might be the good enough. And that comes back to the previous question that we were just talking about, is do you want to play all in the same sandbox and have a single throat to choke to go for everything? Your Kubernetes hosting, your EC2 instances, you're monitoring your observability. When you start to take on a multi-cloud strategy and the additional cloud layers or platforms could be on-prem, not just another public cloud platform, you need to ask yourself, are there best of breed tools and utilities out there that can cross the different vendor platforms between AWS, Azure, GCP, on-prem? So at Ahead, we've got quite a vast amount of experience with these multi-cloud environments, including the spanning of both public and on-prem private cloud type environments. All right, I think we've exhausted all the questions, and we are at time as well. So thank you, everyone, for joining this session. At this point, I am going to turn it over to Ryan and Pam.